Welcome to the video on vectors, equation of a line, angles between lines, and kinematics. So the equation of a line when you have vectors is r equals a plus some constant times b. So a is a point on the line, which is your position vector. B is a vector parallel to the line, so that's your direction vector. So if we draw our coordinates, we have our x, y, and z planes. And you could have some line going through like this, for example. So A would be a vector showing the position, so one point on the line. So this would be vector A. And vector B is a direction vector showing the direction of the line. So it would be something like this. So if A was 3, 1, 2, and B was 1, 3, -1, then our equation for the line would be that r equals A, which is 3, 1, 2, plus some number times B, 1, 3, -1. And we'll want to switch this into our form with our unit vectors, our I, J, and K. So this would be r equals 3i plus 1j plus 2k plus, and we'll multiply this in, so we'll have 1i plus 3j plus -1k. And then we'll combine our unit vectors together, so we'll have r equals 3 plus gamma I plus 1 plus 3 gamma j plus 2 minus gamma k. So that's what your equation would be for the line. We could rewrite that in parametric form, where you have x equals x naught plus gamma L, y equals y naught plus gamma m, and z equals z naught plus gamma n. So you would have x equals, x naught is your A vector, so your position, so 3 plus gamma times L, so your first B value, so 1, so just gamma. Then y equals y naught, which is 1, plus gamma times m, so 3 gamma, and z equals z naught, which is 2, minus gamma, because we have a -1. We can rewrite that in Cartesian by solving all of them for gamma. So this one would be x minus 3 equals y minus 1 over 3 equals z minus 2 over -1. So x minus 3 equals y minus 1 over 3 equals negative z minus 2 over 1. So just negative z minus 2, which is negative z plus 2. So that would be x minus 3 equals y minus 1 over 3 equals negative z plus 2. So here we have it in your normal form, your parametric form, and then finally your Cartesian form. So those are your different forms for writing your equation of a line with vectors. Next is finding the angle between lines. To do this, you would locate the two direction vectors in the equations and then use the equation below, so here, to find the angle where theta is the angle between the lines. So it's just like finding the angle between two vectors like we did in a previous video, but this time you just need to find those vectors in the equations before doing that. Next we have kinematics. So kinematics is motion, and our vector equations describe position and motion. So this equation here, A would be your initial position, B is your velocity, So the absolute value of your b value is going to be your speed. And then gamma is your time. And this can help you figure out your final position. So we'll practice with this in one of our IB practice questions. Here's our first IB practice question. It says, write the vector equation for a line passing through the points 1, 3, negative 2, and 4, negative 1, 2. Then write a vector equation for the line passing through 1, 5, 2 in the direction 1, 2, 1. And finally, find the angle between the lines. So our first line, we're given 2 points. Since we have 2 points, we can find the direction vector by taking your second point minus your first point. So we'll do 4, negative 1, 2, minus 1, 3, negative 2. So that's going to equal 4 minus 1, which is 3, negative 1 minus 3, which is negative 4, and then 2 minus negative 2, which is positive 4. So this will be your direction vector. So then we can just use one of our points. So we'll use this as A, and then this will be our direction vector B. So we get R equals A, which is 1I plus 3J minus 2K. So it's going to be that plus gamma times our direction vector. So 3I minus 4J plus 4K. So then we have R equals I plus 3J minus 2K plus 3 gamma I minus 4 gamma J plus 4 gamma K. We'll combine our terms, so we get R equals 1 plus 3 gamma times I plus 3 minus 4 gamma times J plus negative 2 plus 4 gamma times K. So this is your equation for your first line. Your second line, it gives us the point and the direction. So we'll have R equals our point, so I plus 5J plus 2K plus gamma times I plus 2J plus K. So we have R equals I plus 5J plus 2K plus gamma I plus 2 gamma J plus gamma K, which then becomes R equals 1 plus gamma times I plus 5 plus 2 gamma times J plus 2 plus gamma times K. So there are your equations of your lines. And finally, we need to find the angle between the lines. So we'll use our direction vectors. So 3, negative 4, and 4. And then 1, 2, 1. So V dot W should equal the magnitude of V times the magnitude of W times your cosine of theta. So V dot W is 3, negative 4, 4 dot 1, 2, 1. Our magnitude of V is the square root of each component squared, so 3 squared plus negative 4 squared plus 4 squared. And then our magnitude of W is the square root of 1 squared plus 2 squared plus 1 squared. And then the cosine of theta. So our dot product here is going to be 3 plus negative 8 plus 4, and that's going to equal the square root of 3 squared, which is 9, plus negative 4 squared, which is 16, plus 4 squared, which is 16, times the square root of 1 squared, which is 1, plus 2 squared, which is 4, plus 1 squared, which is 1, times the cosine of theta. We'll continue over here. 3 minus 8 plus 4 is negative 1, so that equals the square root of 9 plus 16 plus 16, which is 41, times the square root of 1 plus 4 plus 1, which is 6, times the cosine of theta. We'll divide by the square root of 41 times the square root of 6 and take the inverse cosine of that. So we'll have the cosine inverse of negative 1 over the square root of 246, and that'll equal theta. So theta is approximately 93.7 degrees. So the angle between the lines is 93.7 degrees. Now we have our second IB practice question. It says a ball is thrown from point 130 meters with a velocity of 425 meters per second. Where will the ball be located after 5 seconds? So this is a kinematics problem. So we have R equals A plus gamma B. So our position, the initial one, would be this one, and our direction vector is this one. So we have R equals A, 1, 3, 0, plus gamma. So gamma is going to be our time, and here it says our time is 5 seconds. So this here will be gamma. So plus 5 times 4, 2, 5. So we have 1, 3, 0, plus 5 times 4 is 20, comma, 5 times 2 is 10, comma, and 5 times 5 is 25. So we just have to add these two vectors now. So 1 plus 20 is 21, 3 plus 10 is 13, and then 0 plus 25 is 25. So this is where the ball would be after 5 seconds. The ball will be at 21, 13, 25, and all of those are in meters. And that's your answer to that problem. So in summary, the equation of a line is R equals A plus gamma B, where A is the position vector and B is the direction vector. In parametric form, it would be written like this, and in Cartesian form, it would be written like this. To find the angle between the lines, you'll locate the direction vectors, then use this equation here to find the angle. And finally, for kinematics, your A vector is the initial position, your B vector is the velocity, where the absolute value of that is speed, gamma is time, and your R vector is the final position. That's all for this video. Thank you for watching.